Welcome everyone to this presentation on the ecological principle underlying a few of our cultural practices we do on turfgrass systems. We will be specifically looking at the self-thinning rule, probably the one true law of plant ecology. The self-thinning rule is based on density-dependent competition. Density-dependent competition occurs when a plant's population's increase depends on population size. Where density-dependent competition occurs is at the carrying capacity of that system. In other words, the number of individuals that the resources in that habitat can support. Thus, factors that regulate population size and density are those that are most important. For example, nutrients, space, and light can influence population size and density. Self-thinning refers to the mortality that occurs when plants grow in size. For example, if you were to observe crabgrass germinating in an open area of your yard this spring, you would notice thousands of little crabgrass seedlings or plants that have filled the area, reaching full cover or the carrying capacity rather quickly. Now come back several months later, and that same area still has a solid cover of crabgrass, but now there are fewer plants, but the ones that remain are much larger and well developed. Over that period of time, numerous crabgrass plants died to make room for more aggressive plants to grow and develop. Thus self-thinning has occurred. Mathematically, we can express self-thinning with this equation, where W is the mean weight of the individuals, C is a constant, and N is the density of plants raised to a negative 3/2 exponent. If we were to graph the equation, we would take the log of the weight and density, which results in a straight line with a negative 3/2 slope. The yellow line here represents the self-thinning line. If we look at the graph a little closer, and future slides I won't include the log on the axis, we can describe the area under the line as a point where we are below full canopy and no competition occurs among the individual plants. The yellow line represents full canopy, or in other words, the carrying capacity of the system. And the thinning or dying of plants as you move right to left on the line is known as the negative 3/2 power rule. Let's look at some characteristics that can be described by the self-thinning line. For example, plant density. If your plant community moves toward the bottom right of the line, the density increases at the expense of individual plant development. If we look at plant development or the size is greater in the upper left-hand part of the line, where each individual is larger, but it's at the expense of certain individuals, so you're not as dense. Texture would be the finest at the highest density and the lowest at the lower density. Wear tolerance is associated with larger, more developed plants, which would be found here. Disease incidence would be the greatest where the plants are the most crowded or population the highest, which would be here. Susceptibility of the community to environmental stress would also be where this X is. Now, let's take a look at seeding rates in the context of self-thinning. If we take two seeding rates of a turfgrass species, let's say the recommended or normal seeding rate, which in this case we can say is 5 or 5 pounds per thousand square feet, and a higher seeding rate of, let's say, 30, or as an example, putting units on it, 30 pounds per thousand square feet as an example. We seed the turf, and at time 1 we can see plants have germinated and emerged, with the greater number of plants occurring as we would expect at the higher seeding rate. At time 1 there is no competition among the plants for both seeding rates because we are below full cover. Now, we move to time 2, we can see the high seeding rate now is at full cover or the carrying capacity, while the lower seeding rate is not, but the development of each individual plant is greater here at the lower seeding rate than the higher seeding rate. At time 3, we see at the lower seeding rate we are still not quite at full cover, but each individual continues to develop as reflected as a weight gain, while at the higher seeding rate mortality is beginning to occur. For plant development to continue, some of the individuals have to die to make room for the more aggressive individuals to grow and develop. Note too, at the higher seeding rate, growth has slowed at time 3. The individual plants are developing slowly, thus remaining rather juvenile, and as mentioned previously, mortality is occurring. At time 4, we are still at full cover, or the carrying capacity, for both seeding rates. But look at the difference in the plant populations of this species at the two different seeding rates. Here we're going to look at an example of mowing. Although the vast majority of plant communities move from right to left on the self-thinning line, in turf we can manipulate that system through cultural practices, like mowing. For example, the green dot reflects where our turf community looks like given individual weight and density at this height of cut. If we raise the height of cut, the community moves from right to left, reflecting more weight of each individual at the new height of cut at the expense of the number of plants present. Now, if we are at this green dot and we lower the height of cut, the plant community will move left to right along the self-thinning line to this point, reflecting an increase in density at the expense of individual development. What if we are at this point and we continue to drop the height of cut to a point below the turf's adaptive range? We end up here, below full cover or capacity, to a point where we have spots or gaps in our areas that are void of plants. Thus we are in a situation of no competition among the plants. Nitrogen is a required nutrient for turfgrass growth and development. Turfgrasses consume nitrogen, and as such we apply it as part of a fertilization program to maintain a healthy turfgrass. Now, if we say the orange dot is where our turf community is at that moment, we can see it is not at the carrying capacity of the system. However, to move it to full cover, we can add nitrogen to promote growth and development. So if we apply nitrogen, The orange dot will move in a diagonal fashion, reflecting increasing density due to tillering, and each individual plant is growing and developing. Now we can make an additional increment increase in nitrogen. And we can reach full cover, or the yellow line. Now if we make an incremental increase in nitrogen, we can potentially move our community down the line, increasing density at the expense of individual plant development. Now what if we are here and we don't fertilize for an extended time? Our plant population now may find a scarcity of nitrogen, which can cause the population to drop below the yellow line into an area that lacks competition, opening up areas that may be invaded by other species. How about moisture or irrigating that turf? Increasing water would look similar to the nitrogen fertilization example we used previously. This concludes this section of the self-thinning rule. In the next presentation, we will look at actual turf situations and see how they follow the self-thinning rule.